Hari. General concepts of fluid flow. In this part, we discuss the ways in which we are studying the fluid flow. One way of considering the flow of fluids is that splitting that fluids into very small sections and study the motion of those fine infinitesimally small parts. We call it as fluid particles. If we discuss the flow in that way, then each and every fluid particle can be assigned with a velocity and also the time. And when we discuss the fluid particle velocity as it is flowing, its components will be there x, y, z, and also the time t. So for each particle, if we assign the position and time coordinates, then the study of the fluid flow becomes very complicated. To come to an equation becomes very difficult. And this study, this concept is actually the generalization of particle mechanics proposed by Joseph Louis Lagrange. Joseph Louis Lagrange is the person who proposed the particle mechanics. But later, Leonhard Euler came forward with another way of treating the flow of liquids, that is, by considering the velocity and density of the fluid in general. So in Euler mechanics or the Euler concepts, we are not considering the particles there, we are considering the motion of the fluid in general at a particular cross section or a particular instant, what its velocity and what its density is. So in this way of discussion, it becomes very easy to make a formula of flow or can study the flow properly. And arriving at a mathematical equation and all becomes easy when we depend on Leonhard Euler method. These are the two basic ways in which we are studying the flow of liquid, but we consider Leonhard Euler method for further discussion of flow of liquid. Now, when we discuss the flow of fluid, to consider or to discuss it in detail, we have to consider the general characteristics of flow. The first one is general characteristics. When we consider the first one is steady flow and non-steady flow. Steady flow or non-steady flow. Now what is a steady flow? Now if I take, for example, there is a tube through which the liquid is flowing. Suppose assume like this. Now as the liquid is flowing through this steady flow, what it says is that at this cross section x, there will be a velocity of 10 meter per second. And here at this cross section y, there will be a velocity of 15 meter per second. And here again, cross section z, there will be, let us say, 10 meter per second. As the liquid is flowing from here through the pipe and out into, okay, if it is a steady flow, every fluid particle which is reaching here in this cross section will be having 10 meter per second speed. And as it is going, its speed will be changing, okay, but when the particle reaches at this particular point, all the particle when it is crossing through this particular point or cross section, all those particles are going to have 50 meter per second speed. Whatever the speed before that or after that is not a problem. When the particle reaches here, it must be having 50 meter per second. So this kind of flow will be a steady flow, we see. Particle will not cross each other, will not obstruct each other, they flow steadily. In this type of flow, see, this type of flow is obtained with a slow movement only. Now any motion against this is called non-steady. In non-steady flow, as the particle reaches one particular cross section, each particle will be having many different speeds in that cross section. So it becomes non-steady. In that case, the particle will be crossing each other and blocking each other, and all those things will be taking place. So first characteristic, steady flow, non-steady flow. Second one is rotational or irrotational. Rotational or irrotational or non-rotational. Now, when we consider the flow of liquid through a pipe, at any point, if there is zero angular velocity, for the flow, then the flow is called irrotational. And if there is an angular velocity or an angular momentum you can associate it with the flow, then the flow is said to be rotational. Now a steady flow, when we consider, there is no rotational effect is coming. To understand that, whether the flow is rotational or irrotational, we insert a paddle wheel inside the flowing liquid. If this paddle wheel is moving without rotation, then the flow is irrotational. If the paddle wheel is found to rotate while moving, then it is said to be rotational. Okay? So, steady flow, non-steady flow, rotational, irrotational. Okay? Then comes next one. Steady, rotational, irrotational. Then comes the third one, that is compressible or incompressible. So the fluid flow can be sometimes compressible or incompressible. Now, This compressible and incompressible effect is understood in terms of the density of the flow of liquid at each instant and at each point. If there is change in density of the fluid with respect to different positions of flow, then it is called compressible flow. And if the density remains uniform throughout the flow, then it is called incompressible flow. Okay. Then the last one is that viscous flow and non-viscous. Viscous flow or non-viscous. Actually, this is not relating to the flow. Actually, it depends on the nature of the liquid. Viscous liquid or non-viscous. Means while the liquid is in flow, if there is dragging between the layers of the liquid or the dragging between the surface, solid surface and the liquid, then there will be a viscous effect is coming. And if there is no such dragging while flowing of the liquid throughout, then it is called non-viscous. So if it is a viscous flow, due to this dragging, there will be energy loss possible. So these are the main 4 characteristics of flow. Then, when we discuss the flow of liquid here, we will be considering ideal liquid. Ideal liquid or ideal fluid. That means that it will be flowing steadily and irrotational, incompressible and non-viscous. So these are the characteristics of what you call an ideal fluid. And all the equations we are going to derive is based on the flow of ideal liquid only. But it is impossible to get a liquid, an ideal liquid in practice. So all the equations that we derive, though it is derived based on ideal cases, okay, based on ideal cases, but practically there are some limitations for all the equations that we derive, that we see in the next session.